In this video lesson, we're going to learn how to prepare solutions using some knowledge of mole ratios that you already know. To do this lesson, you need a copy of the pairing solutions that looks like this. So in chemistry, a solution with a precisely known concentration is called a standard solution. Standard solutions, or solutions in general, can be prepared two different ways. I want you to think about solutions you make at home, because the two different ways we make solutions in chemistry is exactly the same way you would make solutions at home, maybe in your kitchen. The first way of making a solution is by dissolving a calculated mass of solid into a liquid. So this is exactly like how you would make hot chocolate at home. You take a solid chocolate powder and you mix it into a liquid. In chemistry, we know exactly the mass of the solid that we've used because we need that information to calculate the concentration of the solution. The second way of making a standard solution is by diluting a solution with a known concentration. This is called a stock solution. This type of solution preparation is much like how you would make maybe juice from a frozen juice concentrate. You know, those 99-cent cans that you buy at the grocery store. You put them in and you add some water. You're making juice by dilution when you're making your solution this way. We're going to talk about how to make a solution from a solid first, because this is using skills you already have and math calculations you already know. So we want to make 600 mils of 0.35 mole per liter solution of copper sulfate. So the very first thing you need to do is write out your givens. You have a volume of the copper sulfate solution is 600 mils, which equals 0.600 liters. Concentration of copper sulfate, 30.35 moles per liter from right here. And remember, you will always have your molar mass from your periodic table. If you calculate it for the copper sulfate, it's 159.61 grams per mole. Next thing you might want to do is write a strategy line. Decide what you're going to do. So for this example, basically you want the mass of your solid. You have a volume and you have a concentration. So your strategy, you're going to go from a volume to number of moles using a concentration, and then you're going to go from moles to mass using your molar mass. To do this type of problem, I would set up a factor label method. You're going to have your mass of your copper sulfate is going to be, so starting with your volume, 0.600 liter, turning it into moles using your factor label method. Okay. You're going to have 0.35 mole over 1 liter. And then using your molar mass, 159.61 grams over 1 mole. Do the math on this problem, you end up with 33.5181 grams, but we know we have to look at our significant digits, and up here, 0.35 mole per liter, we only have 2 significant digits. So our answer has to be in 2 significant digits, which means it's going to equal round to 34 grams. Okay, so this problem has no new math. We have done these calculations before. However, when we're preparing a solution by dilution, we have a different type of calculation to perform. Before we do that, though, I just want to look at a definition of dilution. Basically, it's a process of diluting the concentration of a solution by adding more solvent. So just remember that adding more solvent does not change the amount of solute. The number of moles of the solute stays the same. Squeeze that in there. When we're preparing a solution by dilution, we use a formula, and our formula is C1 times V1 equals C2 times V2. So the C1 represents the concentration of the initial stock solution. V1 represents the volume of the initial stock solution. C2 represents the concentration of the final solution. It represents the volume of the final solution. So sometimes you might come across this formula written like this. CIVI equals CFVF. This is exactly the same formula. It's used for exactly the same things. The I represents initial and the F represents final. Okay. So another thing I want you to know is that when you were looking at concentration and volume, they are inversely related. What this means is that when a volume is increased, the concentration decreases. So let's look at our first question. Example 1, we're going to calculate the final concentration of H2O2 if water is added to 100 mils of 6% H2O2 until the final volume is 200 mils. So once again, start out by writing out your givens. So our givens, our initial concentration is 6%. That's the concentration of the solution we have. The initial volume is 100 mils. The final volume is 200 mils. And we are looking for our C2, the concentration of the final solution. So write out your formula. C1V1 equals C2V2. You can rearrange or plug in your numbers. We are looking for C2, so we should put that on the left side as proper math form. And in order to get C2 by itself, basically we have to divide both sides by V2. So that means our formula for C2 is going to be C1V1 divided by V2. And then just plug in your numbers. C2 is 6%. And we can just write it as a percent. V1 is 100 mils. And divided by V2, which is 200 mils. I want you to just note here that we did not convert our units for this problem because as long as they're the same unit, milliliter and milliliter, it'll cancel itself out. So if you do the math on this, punch it into your calculator, you are going to end up with a final concentration. I'm going to write it in up here. CF is going to equal 3%. Okay. So copy this down. Make sure you've got it down. We're going to look at example 2. So in example number 2, we want to dilute a 2.0 mole per liter copper 2 sulfite solution to make 250 mils of a 0.5 mole per liter solution. So now we want to know what the initial volume is going to be of the 2.0 mole per liter solution that we need to use. So once again, start by writing out your givens. So our givens, we are starting with a 2.0 mole per liter solution. So that means our initial concentration is 2.0. We want to make 250 mils. So that becomes our V2, our final volume. And we want to make a 0.5 mole per liter solution. So that becomes our C2, concentration of our final solution. And we are looking for initial volume. Okay, so start out with your equation again. C1 V1 equals C2 V2, and rearrange for what you're looking for. So you want V1 by itself. Oops. V1 by itself is going to be C2 V2 divided by C1. Plug in your numbers. C2 0.50 mole per liter. Multiplied by V2 250 mils. We'll sneak in there. Divided by our, oh, I'm wrong. Oh yeah, no, that's right. Divided by our initial concentration, 2.0 mole per liter. You can put that in a bracket if you want. You don't need to. Do a quick unit cancellation. Make sure you've lined this up properly. Mole per liter and mole per liter cancels out, leaving us with milliliters, which is what we want our final answer to be. I'm going to sneak that final answer right in over here. If you punch this into your calculator, you get 62 milliliters. So that's the amount of the 2.0 mole per liter solution you need to have to dilute it to equal 250 milliliters of a 0.50 mole per liter solution. Okay, so that finishes our lesson on preparing solutions. If you are a little stuck on this, we will do a couple examples in class, and I have some practice for you as well, but it's fairly straightforward and doesn't use any skills that you don't already have to solve these. Okay, see you next time.